Let's recap what we learned in the previous lecture. So previously, we are looking at rectilinear motion, and we assume it continue to move. Okay, so this is what we learned previously, and what is important for the previous section is the definition of dynamics, or how you describe the motion of a particles. We are now in the particles chapter. Where we look everything as one body. So we define by position, velocity, acceleration, and time. So this is position, velocity, acceleration, and time. So all these, they are vector. Vector have magnitude and direction. Okay, so by using this 4-parameter, position, velocity, acceleration, and time, we can define displacement, which is the end position minus the earlier position. Okay, this is displacement. Okay, so there's a difference between velocity and speed, right? So speed is a scalar vector of scalar dimension of velocity. So from displacement, we come up with the definition of velocity. V equal to time differential of your displacement, right? Time differential is a differential equation and it's not a simple division kind of equation. All right. So what is acceleration? Do you remember? What is the definition of acceleration? Huh? Okay. So change of velocity and time. So it's a time differential of velocity. Okay. Now there's one more. You can write acceleration in terms of displacement. So how you do it? You differentiate the velocity. So you differentiate, you substitute v equal to ds dt. Is a double differentiation. So become d square s dt square. Okay. Now there's another one. First equation, second equation, third equation. There's one more where you freeze the time and you look at the t dimension. Okay, so you freeze the time and you rewrite the dt over here. You will arrive at a dv a ds equal to v dv. Okay, so this previously we learned and we come up with the Newton motion equation. This term only appeared in my class. You won't see this term in other textbook. Right. Now, when we have a scenario, you can derive from all these definition here. You arrive at 3 equations. V equal to VO plus AT. Second one, V square equal V0 square plus 2A delta S. There's one more. One more. Delta S equal V T plus what? 1 over 2 A T square. Okay, So these three, and to use this one, acceleration must be constant. To use these three, acceleration must be constant. If not, you unable to use or inaccurate calculation, like we show in the tutorial question. Now today, we learn something a bit extra or new. It's called erratic motion. So previous class, we learned about continuous motion, which is continue to move. But today, we learn about and particles, it move and then stop, or it slow down, or it accelerate. So how do you tell the story of the motion? Today, we will focus on something, we'll use graph to represent the motion of the particles, which is very important for your assessment. We're going to learn three graphs. One is VT graph, velocity versus time graph, acceleration versus t graph, and sorry, there are four graphs. V versus displacement, acceleration versus displacement. So you have VT, AT, and then you transform this one to this one. Later I'll teach you lah. VS and AS. Okay. Now, it's easy to convert V to VT to other graph, but I've seen cases where students have difficulty converting information into displacement graph. Okay. And in my tutorial, there is a lack of information about that, but before the test, please request me to discuss example of VS or AS. Please request. Remember to request. You don't request, I will forget, and the question will still come out. So you don't know how to do, then don't blame me. Okay. So I will only discuss upon request. All right. Now let's do a little bit of theory. So the rest you read. Today we want to describe the motion of an erratic motion, means a particle move and then stop, or it accelerate and so on. So the earlier section, you're not able to tell at the end. So now we want to tell the story from start to end by using graph. Okay, by using graph. And just a heads up, you need to recall dy dx differential scale and integration of your x dx, y equal to x dx integration scale throughout this section. Okay. Right, so we're going to introduce you the three graph. One is S versus T, which is displacement or position versus position versus time. And the second graph is velocity versus time. The third one is acceleration versus time. Okay. Now, before we move forward, again, we have three kind of graph from the mathematics. First, linear graph, which give you y equal to mx plus c. Okay, makes sense. This is y, this is x. So what is m? M is the gradient of the line. How you find the gradient? dy dx is your m, is your gradient. Make sense? Okay. Second graph, quadratic curve. So it is y equal to ax squared plus bx plus c. How you know the shape of the graph? Again, if you a more than 0 or positive, you get a smiling face of the curve. If your a less than 0, you get sad face. Okay. And back to the linear, what I mean by the C? C is the intersection of the graph. Okay, the third one, polynomial. It is your y equal to ax cubed plus n something. It is your index or your exponential is more than 2. Okay, so going to learn about this one. So we're going to look at these three graphs. In the question. So if you see question in the y equal to ms plus c, then you draw a linear graph. If you see the equation is quadratic, then you draw a quadratic graph, and polynomial and so on. Okay. So we look at the first one. Position versus t graph. So s versus t, you imagine this is y, this is x, your x is your y. For what you understand plus c, what is the gradient? The gradient is dy dx is your m. Dy dx is gradient of the graph. So f t. So you can just take position versus time, or not position divided by time. Position, the unit is meter, time is second, meter per second. The gradient will be what? Will be what parameter? Which one? Which one? Acceleration? Velocity, yeah? It will be velocity, yeah? Because meter over second is velocity. Makes sense. Okay. So let's say you have a curve there. Let's say you have a curve. And you have point number 1 on the graph, right? So usually in a question, it will tell you first position at where from the reference point. So time, like for example, a vehicle start from starting point and it reach a certain position, 10 meter from the starting point after 10 seconds, for example. So how you plot the graph? You start with the first position, right? And you mark position time 1, t1 here, and then mark the okay. So you have T1 and S1. Clear? So far clear? Right? So what happened if the object continue to move? Right? So I already explained like how to get the gradient of the slope. So the slope from this equation here, we get from the earlier definition, V equal to time differentiation of your position, right? V equal to ds dt. To get the velocity at this point, you need to get the gradient on this point, right? So previously mathematics, how you get the gradient of a curve? Let's say you want to get a gradient of this curve, of this point number 1. Gradient equal to dy dx of a curve, right? You get a gradient of this one, right? In the what you learned in the mathematics. So we apply the same on the S versus T graph. Same, right? So we can plot every point on this graph. S versus T graphs, like point number 1, you do dy dx dt, you get the first. Then you find other point graph, you can convert S versus T graph to V versus T graph. Make sense? Make sense? Okay. Meaning I can convert or This is the first step every time you see the erratic motion kind of question. The first graph, you always start with S versus T graph, and then you copy the axis, same on your paper. You draw V versus T graph. Because the time is the same dimension, so what you do, you draw a line will represent T1, T2, T1, T2. Then let's say you have a point on this part, right? This is point number 1, S1. No matter what is the shape of that on that graph, we just convert the point into dy dx. S versus t, you get v, so you get a v term here. So this is the first point. So when you get dv, dy dx, you get the v. So or this one is ds dt. You'll get the first point here. Okay, this is your v1. Okay, this is point number 1. Point number 1, but this is in v. Same. Let's say you have the second point. Second point, same. You do the same. ds dt, you get the gradient. Then you have second point here. Makes sense. Okay. So you can convert S versus T graph into V T graph. Okay. On the slide here, it's just an illustration. Don't get confused by the blue line here. The concept is still the same, right? Convert and then convert point to point accordingly, right? And always start from 0. Okay, any question here before we move on? Make sense? Okay. Next. Next. How we plot AT graph? How we plot AT graph? You continue, you continue, build the third graph, AT. My recommendation, you always do this kind of question in the same page, right? In A4 paper, you draw the 3 graph, same page, and then you draw the timeline. Just this one is you don't do a very strong line, but you just do a dot line there, and then you label T1, T2, T1, T2, T1, T2, and so on. Then the first one, ST, VT, AT. Okay, so this will help you to see the motion of the object. So the third one, how we establish AT graph? Okay, so from ST to VT, you use differentiation, you use ds dt, differentiation. Then how you connect AT, how you get the AT information from ST and VT? Again, recall the definition of what you learned in the previous section. How you link position and time. When you take position and time, you differentiate with time, you get velocity. You get, when you want to get acceleration, you take velocity and time. And there's one more you can get from from position for acceleration. But this one is double differentiation. Okay. Now the most easiest way is you directly use the definition. For example, you want to get V versus T graph, you use ST. You want to plot AT graph, you use VT information. Okay, so you just follow this flow. S versus T graph will generate VT graph. Vt, you want to generate At, you also use time differentiation. A equal to dv dt, you get At graph. Which means you also use dy dx, time differentiation methods. Make sense? Okay. So this is the flow from S to V to A. Yeah, so I'll just show you something. So let's say you have an acceleration with a certain curve on inside from the question, and you have the first point there. Again, mark point 1, and also do the same, put in T1, and you calculate how you get this number. There is an equation you need to establish, get this equation. Then you substitute time inside there, then you get one value there. Okay, so you get A1, and so on. Okay, now just now we move from ST, VT to AT. So if the question straight away give you AT graph, it asks you to develop VT and ST graph. How do you think you're able to convert AT to VT? What do you think? Huh? Integrate, huh? So when you reverse back, you A to become V. Again, recall the definition that what you learned in the previous section. A equal to dV dt. So you want to reverse it, you can rewrite, reverse, you can rewrite A dt equal to V dV. Why? Because in the VT and AT graph, you are converting A and T graph into V information. This graph is A and T information. So you want to convert this one to V information. Let's say you have a point here. This point is AT information. So when you take this information, AT, you do integration because you see dt dv here. So you do integration. So A dt actually is A multiplied by time. So A multiplied by time is actually area under the curve, this AT. This integration means area under the curve. All right. So just recall back that you learned in your mathematics, right? Mathematics. Let's say I use the linear graph, y and x. This is y equal to mx plus c. Let's say I have 2 points, point 1, point 2. So the gradient m equal to dy dx of y2 minus y1, x2 minus x1. This is what you learn in your basic mathematics. So what happens if, what happens if you want to find the area under this graph? You do integration, right? So area under this graph equal integrate of your y dx. Right? Integration, you find the area under the graph. So what you do, you will get the area. So m is the constant. So let's say you have a limit here, a and b. So I can you do the integration lah. So this one you get some number. So when you want to get area, you do integration. You want to get gradient, you do differentiation. So same. So go back to these slides. So AT graph, each point, if you know the definition of equal to dv dt, you move AT to left-hand side, AT equal to V dV. So you do integration, you can find the value of velocity. You take acceleration multiplied by time, you actually get back the velocity. Mx divided by mx cubed, because the unit of acceleration, okay, unit of acceleration is meter over second square. When you take acceleration multiplied by time, you cancel the unit, you get meter per second. You get velocity. Okay. So it's the area under the graph. So what I highlight on there, but it's the same like what I did on the whiteboard there. Okay. So on the left-hand side is a change of velocity. You integrate this equation, you get V2 minus V1, right? The upper limit minus the lower limit. This is 1. Right? Right. So you can plot the graph. Okay, you can plot the graph. So the highlighted area that in the red color on the screen is a delta V, which is integration of your acceleration and time. Okay, from this area, when you calculate, you get one number. You go to the VT, you find the magnitude of V, then you plot. The time still same. You copy the time, copy the time. This is still T1. But the value for V is from your integration answer here. Make sense, Make sense, Okay. And try not to forget, in VT graph, the one that intersect with the y-axis is your initial velocity. Means your time is 0 here. Time 0 means the starting point. V initial is here. Sometimes the question is quite tricky. You can find the answer of initial at the time 0 after you find the equation of its curve. It's not that direct. So you move one step to one steps, so you get V1 and so on. And then from the initial, you take V1 minus VO, you get the change of velocity here. This is on the curve, on the graph. Make sense? Okay. Now we have shown you how to convert AT to VT graph. Are you able to do the same for VT back to ST? Again, recall the definition of velocity. Velocity equal to time differentiation of your position. So again, when you reverse back, you do integration from the equation. V equal to ds dt. You move the dt to the left-hand side, you have ds, and then you integrate both sides. V multiplied by t, you get displacement, or you get position, right? Velocity, meter per second, multiplied by second, you get meter. So you get position. Right-hand side is your position, change of position. So they are same dimension. Okay. So you repeat the same for ST. So let's say you have a VT graph that you have derived, right? So you have position 1 at the T1 and V1. Then you turn this one into ST graph. You use the same approach. You integrate it. So the left-hand side of integration, V dt, is the area under the graph. And the right-hand side, answer for S graph. Okay. The red color region, it becomes one dot on the ST graph. Okay. Ignore the shape of the blue line because it might be different when you do calculation later. I just show you that it might be turn out to be different form of equation, right? Important is the position of that red cross, red X there. Okay, again, not to forget, At time 0, there is a initial position, S0 here. And then from the S0, it will help you to find the changes of position or your displacement. Okay, you take S1 minus S0, you get your delta S. Just don't forget this point. Because as you forward, you learn more things, you will tend to forget this information. Okay. All right. Now, just to summarize, the procedure of converting AT to VT, you always start with, to be easy, you always start with ST graph. Then you move to VT and AT. So when you move ST to VT, you do differentiation, dy dx. V to A, you use dy dx. And if you move to the left or you move backwards, let's say you start with VT graph, you move backwards. VT convert back to ST, you do integration, right? Okay, y dx. Then you move from AT back to VT, you do integration also. Yeah, so that is the main thing that I want to explain for this morning, as long as you understand. All right, you always start with something, ST, VT, AT, and then follow the flow. Then if the question gives you VT, you need to do ST, what do you do? VT, you want to plot ST graph, what do you do? You do integrate or differentiate? Huh? Yeah. So I just ask you a question. Okay. So you start with ST, you want to start with ST, go to VT, you do integrate, you do differentiation. VT back down to AT, you do differentiation. So you want to start from AT, you move back. AT convert back to VT, you do integration. You move VT back to ST, you do integration. So this is one-way flow, one-way flow. What if the question, it give you VT graph? You want to convert back to ST, what procedure you use? Integrate or differentiate? Huh? Integrate. Then you go from VT to AT, what procedure you use? Differentiate. Okay. So to the left or go down or go back to the original ST, or move up or move down. It depends on your study style lah. All right. So the main idea is you move as you refer to whiteboard, what I write, what I draw here. If you move from ST down to AT, you do differentiation. If you move from AT back to ST, you do integration. So this one will be your cheat code lah. The way you understand that. Okay, now the question give me this. I want to work back. Then how do I do it? It makes sense. Now we go to the more challenging part. It is you converting dimension of time into displacement. So I need to go it a little bit slow because this is also quite popular when it comes to final exam, and most of the students, they will give up when they see this kind of question because they don't know how to proceed to the next steps. Okay, now we look at AS graph, or acceleration and displacement graph. So let's say you have for first point landed at position 1 and with the acceleration 1. Okay, and then we have an initial acceleration when they're at a starting point, S0 here. S0, you have a O there. So how do we turn into VS graph? You cannot use the procedure that we learn, like what I write on the whiteboard. Because here is a time dimension. You cannot directly follow this one into S. There's a different method already. So don't miss out with the one we write on the whiteboard here. There is a certain procedure you need to follow. So first position, the dimension now is your position and not time. So S1, S1, V1, O1. Okay. This is the objective that we want. Again, there's okay. Okay, so this is what we want to achieve in this time. So we want to convert AS into VS. Okay, so there is something missing here. I think in my slide I don't teach you how to convert VT into VS graph. There's something missing in my slides here, but I will discuss during the maybe next class or before the exam. I will show you one example of final exam or test 1 question that will convert this one. Okay. Maybe next class I will show you. All right, I will show you. Okay. So let's say you have one graph. Okay. As VS graph, the procedure, you need to recall this equation. A ds v dv equation. Because this equation is A ds and v dv graph. Because the graph you have is AS and VS graph. So that's why you are using this equation rather than other. Other is time differential. This is time differential. This is link you with the position or displacement with the velocity and acceleration. Okay, so this is the one that you're using. Okay. Right. Now on the slide here, you see a few equations. dt, ds, dv, dt, dv, a. So, and then you move them around. You freeze the time. Again, you freeze the time. When you convert from the time graph into displacement graph, you need to freeze the time. You need to freeze the time. You need to hold the time. You need to hold the time. So you need to use this equation because this equation derived from you freeze the time. You pause the dt, right? You pause the dt, then you right. Okay, so when you integrate, you see A ds equal to V dv. When you see d something, very automatically you put in the integration sign. So integrate A ds, you will get, and then integrate V dv. This is V. So V integrate V, your V power n plus 1 divided by n plus 1. Okay, so because this is you integrate the same parameter, so there's a procedure there. So when you integrate that one, you'll get half V1 square minus V naught square. Do you need me to derive the equation for you? Do you need me to help you? Or you can do it? Okay. So I'll write something on the whiteboard. So we have A ds equal to V dv. So before that, I recall y equal to, let's say, AXN. X, D, X. All right. So what you do with this procedure, you move the A outside. Okay, you move the A outside. Then you substitute with the limit here lah, L1, L2. Okay, L2, L1. For example lah, but in your mathematics, maybe this one have one number there. Okay, or B, A. So by using these integration general steps, you apply to this equation. So this is what? This is your x. This is x. Right? So you integrate v dv. So v above the here is 1. Right? So when you integrate, what you do, in front the v is, so you pull out the 1, you still 1. So v 1 plus 1 divided by 1 plus 1, and then you substitute the limit here. Limit here is v1, v2, so v2, v1. Sense? Then here you arrive at v squared divided by 2, v2, v1. Then you substitute v2 squared minus v1 squared. Right hand side, I didn't do anything. I just copy. Right, you just copy. You arrive at this one. Make sense? But in the slide, I use v1 and v0. In here, I use v1 and v2 just to okay. Yeah. So this sub 1, sub 0, it depends on the graph point that you are referring to. Okay. Okay? Make sense, huh? Everything makes sense, huh? Okay. So from here, on the left-hand side, integrate A ds. You look at the graph. This graph is A ds graph, AS graph. So when you integrate something, you always get the area under the graph, right? So on the left-hand side is area under the graph. On the left-hand side is velocity. It's a square of velocity, right? It's a square of velocity. So when you freeze the time, you're able to plot point number 1 over there, v1, v2, you're able to get the velocity there. Okay. So you need to substitute the velocity, the initial velocity there. Yeah, you need to substitute velocity so that you get this point. Okay. Okay, the rest you read from my graph, from my slides. All right. Okay. So now we relate acceleration with time. So from A ds equal to v dv, we rearrange it so that we get our A equal to v dv ds. We take this one. Okay. So go back to your Vs graph. Vs graph, the slope again is v ds. This point, there's a slope that you can calculate, or the gradient you can calculate. This is y and x. You on any graph, if you have that, you can calculate by using dy x. In this case, your y is v. That's why your slope is dv. The ds is right. Okay. So the height of this one is actually this equation, A equal to V dV dx. This mathematics. Okay, this mathematics. Okay, let's look at example. Then we call it a day. Go very fast. Again, remind me to show you the example of converting VT graph into VS graph. Remind me to show you that. Okay, now let's say you have a bicycle that moves in a straight road. Again, when you look at the question, you know this. If you see something straight, then it's chapter 1 question. Because it's a rectilinear motion, right? Shown below, it means this tutorial question gives you a graph. Construct VT AT graph for time from 0 to 30 seconds. Okay. Again, all this question is available in the Canvas. You just go to the Canvas, download the tutorial for chapter 1. Tutorial question for chapter 1. You see all these question without answer on the Canvas. So for the next lecture, maybe you can download the information from the Canvas and then you come to class. You don't need to copy all these things, right? You only need to fill in the blanks or this. It will help you on your learnings. So you're given one graph like that, S versus T, and then there is a graph like that, right? So you're given some time there, right? You're given some time. So T 10 seconds, it reached 30 meter. Time equal 30 seconds, it reached 150 meter. So you have this kind of graph. Before you go into, you recall what you learned in your mathematics. You look at the graph. You have 3 kinds of graph: linear, quadratic, and polynomial. So from 0 to 10, what kind of graph you have? 0 to 10. What kind of graph? Linear, quadratic, polynomial? This curve? Quadratic? This one? Here to here? 10 to 30? Linear. So you have to, before you go move forward, your mind have to be very clear what kind of equation or what kind of graph that you are dealing with. Because if you see the graph shape, you know in your answer later, you will see quadratic equation, you will see linear equation. Okay. So, but if you see linear equation, but later your equation come out, how come I see quadratic equation? Means you need to question your answer already. So you're given the equation for the graph. So this is the first question. Sometimes the equation will not be given. In the test, you reverse the whole thing. You need, in this case, we give you everything. So when it comes to test, you need to reverse the question. So S equal to 0.3 t squared is a quadratic equation. The second one, it gives you another equation, S equal to 60 minus 30. So 60 equal 30, this one, Y equal to mx plus c. So from here, you know your gradient, you know your intersection when the time equal to 0. Okay. So how you move from ST to VT? You do integration or differentiation? ST to VT. Differentiation. So differentiation, recall definition. Now you have ST. Now you want to do VT. Recall. Write something on your answer. V definition is the SDT. Write this one in your answer. Shape. From here, this is gradient. You know you need to find gradient, right? So ST graph equation. We use the first equation because you're converting ST to VT. The only equation that link with S and T and V is this equation. The other equation is not relevant, so don't look at them. So only look at this one. So this kind of question, you look at time to time, means slot. You have 2 slots there. You don't complete the whole graph. You don't look at the whole graph. You look at number 1 to 10 first. Then you look at 10 to 30. Don't confuse yourself. Do one by one. So you look at the time, first time slot 0 to 10. Okay, 0 to 10. So 0 to 10, you have one equation on the graph, which is s equal to 0.3 t squared. How you use this equation with that equation? How you link s equal to 0.3 t squared that help you to build the v? You integrate this one, right? So you integrate ds dt, what you get? How you do integration? Differentiation. You move the 2 in front, 0.3 t 2 minus 1. So you get 0.6 t power 1 or 0.6 t. Your ds dt is a what kind of equation? Linear, quadratic, polynomial? Linear is in the form of y equal mx plus c form. Your c here is 0. Okay, so I do the first one for you. S equal to 0.3 t, and the second one is equation. So you do the differentiation. And ds dt is what? Is v. ds dt is v. So you're plotting the v dimension, the v graph here. Make sense? You're actually plotting y equal to ms plus c graph. V t graph in the y equal to mx plus c from what? 0 to 10 seconds by using mx plus c equation in this graph. So you only have 0. You substitute 0 here, you get 0. You have 10, right? Substitute 10 here, you get 6 here. This is a linear line, so use your ruler, connect this line. Make sense? So remember, this equation is important in the test. V equal to ds dt, you differentiate, then you write 0.6 t. Unit is important. Don't miss out the unit. You miss out the unit, automatic discount 50% from the full mark, from the answer full mark. So you do the same for the second slot, 10 to 30. Also time differential. Why? Because the objective is to derive the VT graph. You do the same. Differentiate this one, you get 6. Full number or constant value, you differentiate, you get 0. Okay. So you have two number. How you plot this number? There's sometimes I see students stand there. They don't know what to do with the full number. Okay, I recall. This line is what? X. Let's say this is 1. X equal 1. This is x equal 2. This is yx. So this is y equal 1. So y is 1. Y equal 2. So this one, v equal to 6. What is your y-axis? Your y-axis is v. So v equal to 6. So you go to you draw one line and then you label 6. Okay. So you convert st, you draw the axis v versus t graph. First equation, 0.6 t is like that. Y equal to mx plus c. You draw a line, you find the dot there, right? You put in the time frame, 10 to 30. Then you draw a dot line. At 10 seconds, what is your velocity? You substitute here. You get 6, right? Get 6. Then here, v equal to 6 is a straight line of 6. You draw one ruler, use straight line, and then you draw a straight line. And then you write equation for this one and this one. Then you complete already. It's very easy to score for one. Okay, so this is just a double conformation. How you get 6 at this here? If you use the normal graph analysis to get the velocity, from here to here, how you get y2 minus y1 divided by x2 minus x1 to get the gradient. If you use the graph method, to get gradient, y2 minus y1 divided by x2 minus x1, still the same, you get 6. But since you're in your degree level already, you rarely use this method anymore. You use differentiation straight away. Okay. Okay, AT graph, I will put it as your homework, but all the information is there. Right? It's the same, but in principle, when you have VT graph, how you do? VT to AT, what procedure you use? Integrate or differentiate? Differentiate. Repeat the same process, you will get the answer. I give you the answer. You repeat the same, 2 slot, you find the equation, right? You find the equation, then you plot. For example, the first one, A equal to get full number. Full number is a straight line. Then the second one, you get 0. 0 means here. You draw a line here. If your answer is on the axis, please draw the line on the axis. Okay, so this is the expected answer for example number 4. Okay, so we end our class here. Okay, let me. Previously, we say that we want to change the timetable, right?